Good morning, everyone, or good afternoon, depending on where you are around the world. Welcome to today's webinar. We are going to be looking at a few project-specific techniques that often come up in mining applications. So we're going to be creating a pit, measuring the earthwork volume of a stockpile, and designing an access road. We will also be doing a quick demonstration at the end, so if you want to stick around for 15 extra minutes, about earthwork optimization for that haul road or that access road. So let's get into it. Here is our quick agenda for today. The concepts we're going to cover, as I've mentioned, we're going to be looking at creating and grading a pit, calculating stockpile earthwork volumes, designing an access road, and lastly, that bonus haul road or access road earthwork optimization. All of this is going to be done in our RoadEng software. The exception of the last part, it is RoadEng, but we've got our Softtree Optimal Earthwork add-on that we're going to be using. So with that very short intro, just a friendly reminder, you guys are all muted, but that doesn't mean we want to hear from you. Please ask us questions. You can do so at any time through expanding the little Q&A section in your GoToWebinar panel. Type in your question and we will absolutely get to it. Probably stopping at the end of the core content and then do some more questions at the end of the optimization, just depending on how we're running the time. So with that, I'm going to pass it over to Matt. He is our resident webinar expert and training manager. Over to you, Matt.
All right. Well, thanks for the introduction, Erin. Yeah, and thanks everyone for attending. So I'm going to start out. We're going to do the start sharing my screen first here. So we're going to start out with the terrain module of our software. We're going to use that to create our topo surface. So for this example, we're going to use a DEM data set. We're going to create our topo, look at our contours. We're going to bring in some ortho imagery, and that'll be that. Then from there, we're going to use that topo surface as a layer, and we're going to grade for our stockpile and our pit with that as our target surface. So we're doing all that in terrain. We're going to use separate instances of terrain for that, and then we're going to switch over to location and design our road. So I'm going to open up terrain, and I should just mention too the project I'm using today. It's a fictional project for us. I just went online and found some publicly available DEM data that happened to overlap with the mine. So, yeah, so it's not representing an actual project. So in terrain, insert file, DEM, and I'm grabbing my DEM files here, so they're TIFF. Oh, actually, I skipped a step. Since I don't want all of the extra area in our surface, I'm going to add in a feature to thin that off of. I've got an area of interest, it's a shape file, projections carried with it, and there we go. Now I'm going to grab that DEM, and here I'm presented with the option for selection. So I don't care about all of the topo surface points outside of my area of interest, so I'm going to thin based off that feature. The remaining area, I don't care about the points in it, so I'm going to skip all of them. We'll hit OK. It's going to take a moment to bring in the DM points. And there they are. They're being drawn. I'm just going to hit Escape. So the points are still in there. They're just not being displayed right now. So to create a surface from that, I'm going to click Terrain Modeling, Generate, and I'm just going to make the surface here. So we've got that set up here. Maximum side length refers to the maximum edge length for triangles, and I'm not going to generate contours at this time. So that's taking a moment to create the surface. Surface gets created fairly quickly. Contours get created fairly quickly as well, but they take a little bit longer than the surface. So it would probably take a couple of minutes to create the contours for this example. check our surface in the 3D view. So, and I'm going to add my contours in. I'm going to cheat a little bit for when I add those contours in. Just wait for this to calculate first. There's our surface. So yeah, if usually when I calculate my triangles, I would have turned on contours here and they would have been generated right away. Just to avoid waiting a minute or two for that to take place, we're going to add them in as features. So there they are. Now another thing that we can do, so right now I could hit save and we could go and we could design our stockpile and our pit and our road from this. So let's just hit save before I forget to. We'll call this file OG for original and then topo. It's nice to have a little bit of context for what's going on here though, so I'm going to pull some ortho imagery from the web. Just waiting a moment while that file saves. So we've got around 5 million points in our file, so it's not tiny, it's not massive. So that's saved. Now I've got my feature selected. I click import from web mapping. Since we're using projected data, we can see where we are. So I'm going to crop the area of interest and hit save. So this is just getting downloaded from Google Earth right now. We've got other sources that you can add in to bring that in. So by default, Google Earth, Bing, MapTiler are there. You can also add your own providers if you have those as well. And so this is the download right now, and then it'll switch and stitch the images together. And then we'll be presented with a few dialog boxes that we won't have to do much with. We might adjust the image quality to get full resolution, and then we'll have a reference terrain file in the background here. So let's just save that. Transformation is being done automatically. We'll turn the resolution up. And we are good to go. So we've got our topo surface made. Now let's getting into designing. So just looking at the operation here, we've got this waste site over here. So I'm going to plan to see how much more material we can spoil or waste in this area. So we're going to design a stockpile, figure out how much volume we can place there, and then we'll also design a pit down here. After that, we will design our haul road to get to that pit, to the existing infrastructure. All right, so switching to another instance of terrain. I'm going to set options. I'm going to add those other files in as backgrounds. Let's see where we're at. So there's that. And we're going to add another one just so we can see the image. Shift that image up. Now, I'm going to design my stockpile here, so I'm just going to create a new feature. or whoops, do that. Drawn with our mouse. And let's just outline the existing pile. Let's assume we want a 20-meter wide bench on the outside of this just for access. So I'm going to use the buffer tool. The direction I drew the feature was clockwise, so I want to grade to my right, or buffer to my right, and we'll offset 20 meters. All right, so now I'm going to use the grading tool. One thing we'll look at, so I'm just hovering over my background, I can see the tin elevation. So at here, my tin elevation is 380. Here, we're 400. So I'm going to change this to include elevations, and I'm going to shift it. So right now my elevation doesn't make any sense, so let's do a quick shift. There, that's up around where it should be. Now we're going to use the terrain modeling, grading, and we'll grade to the inside, and we'll set a target elevation of 20 meters higher than the original, so 420. We'll interpolate spacing. So right now, if we don't interpolate, it's just going to draw the slopes in from all the points. So let's do 10-meter intervals. We'll use a slope angle of 1 to 1. And away we go. Oops. So what's this look like here? We'll zoom to extents. You know, we've got somewhat funny behavior, and that's just because this is set as our tin boundary. The generated feature, we're going to turn that off. Turn this one on. We'll remodel. Actually, it doesn't take much time to add the contours. And there we are. So we've created our own stockpile from scratch. Now, if we had an existing stockpile, we could do the same thing as to get volumes. So I'm going to calculate volumes. We've got our surface here, and we're going to compare it to our target surface of that OG topo. And there we are. Now this is saying our surface A, which is our current surface, is original. We want that to represent final in this case, so we can see we can fit a fill volume of 1 million cubic meters there. So that's our stockpile. Now let's talk about designing our pit. So our pit, I'm going to design our pit. I'm going to insert the an area of interest for that as well. So rather than me blindly deciding where to put things, I've got a shapefile that I want to represent my pit bottom. And we've inserted that in here. So for this, I'm going to check the direction that feature is drawn in. So I'm just hitting next, and I can see it's going clockwise as well. I can see my elevation is at 230 meters, and around here, that's going to be in cut. So let's use the grading tool. Instead of target elevation, we're going to set our target surface to be a topo surface. And again, we'll interpolate spacing. I was expecting this to look funny here too. So this is because my maximum side length is only set to 200 meters, and this is quite a large distance across there. So let's change this. So there, we've got our pit here. We've got our pile over here. If we want to report these volumes separately, we can do that. So we can have the two surfaces in the same file, and I'm just going to change this to be a surface volume boundary. I'm going to call this pit. And I'm going to call this file. And we're going to turn this surface volume boundary on here. Now we're going to use this calculate volumes, and this time we can separate the volumes by polygon. So this will just take a moment to calculate. Oh, I think we've got a question here, and let's see if I can, for some reason it doesn't want to show me that.
So I can read the question for you, Matt. It's how would you put in a safety bench along the cut slope?
Oh, perfect. I actually kind of expected that question to come up, being in a mining world. So let's, we'll just deviate here while this calculates. Oh, I guess this is done calculating. So there we can see the report for the two different areas. We've got a little bit of noise here, and that just comes down to how we're, how frequently we're interpolating points. And, yeah, just some, we may have a slope line hit a triangle face outside of a point kind of thing. So that's that. Now for benching, I'm just going to bring up one that I've already looked at. So this will take a moment to open. And there, so I've gone through and made a pit fairly arbitrarily here. We've got the, probably the same feature as I used in the other design, but let's just take that, paste it, move it over here, and I'll talk about what I did to get this generated. So here, if we know the base elevation of our pit, I just took that feature, and instead of using the grading feature, and there's a few different ways you can do this, but this is would be my preference. Use the buffer tool. We buffer, say I want to go up 20 meters at a 1-to-1 slope. So we've got that. Then I'll select this next feature. I will buffer, let's go 10 meters. I'll set that at 0. Oh, and I buffered it the wrong direction. Modify buffer. So there's our bench, and you just can continue on like that until you get something like this. Now the issue with this is we're extending out where we don't want to. Obviously, you're not going to build benches out into space. So the way I would prefer to tackle this is using this calculate volumes. We can calculate a surface intersection feature. And then I'm just going to use that surface intersection feature to trim out the stuff I don't care about. Hopefully that doesn't take too long to...
Awesome. And Matt, it actually looks like you have tackled our second question while dealing with the first, which was how do you add multiple benches? So well done. If either of the two question askers have further questions, good opportunity to punch them in as well.
All right. And that, I'm kind of surprised how long that's taking. It usually goes quicker than that. Oh, there we are. So that's calculating some other stuff, and I don't know whether it's best to move on to something else or wait for that. Let's just open up location here while we wait for that. So we've got our as a recap for our pits and piles, we've got our pits and piles. We did that in terrain. We designed our own pits and piles in this case to figure out volumes. One thing I will mention, if you're doing if you're trying to figure out the volume of an existing pile, for example, or how much material is removed from an existing pit, you can use that to calculate volumes, and you can do a tin subtraction between two surfaces. So if you generate your line work for that surface, great. If you base it off of survey data, you can do that as well. In the fairly frequent case that you have a stockpile, say in a pit floor, and you may not have original topo for that pit floor, you can do a calculation based on a single point. So just delineate the outside of your feature, and it's going to assume a planar slope underneath that, and you can get volumes from that as well. So back to this bench. So here we've generated a feature that intersects the ground. Let's just select that feature. I'm going to modify break at current feature. I'm going to hit delete. So I'm going to reselect that feature. And let's do select by boundary, outside. Don't want to retain the feature. And we'll delete that as well. I'm going to set this as my tin boundary. Hit OK. I'm going to recalculate. And there, we've got our benched pit. So fairly flexible. There's other ways you can do that as well, just playing with the grading tool. You can also delineate your benches at odd intervals. I just use the buffer tool because that's easy. But if you want to have something that's not at a fixed width, you can do that just by drawing it in by hand. Other useful features are shift to shift your elevations around, or coordinates if you want to change the coordinates of a specific point. So there, we've got our stockpile and pit addressed. Let's switch over to location. So terrains where we do things like pits, stockpiles, grading, location is going to be where we handle the linear infrastructure side of things. So for this, I'm going to create a new file. I'm going to reference that original topo surface that we were looking at. There we are. Hit OK. And let's just save this as well. And pile. We're just going to start with a single point at the center of our terrain for an alignment. And there we are. So first I'm going to add in those background files. So I want my image in there. I'm going to just change the washout so it's faint. And I'm going to add in our file. And I'm just going to change the color of that so we can see it a bit easier than gray on gray. there we are. We've got our background set up. Before we start adjusting the alignment, I'm going to change my cross-section geometry. So the software is a 3D software. As we move the alignment around, it's going to update the various views in real time. But the cross-section geometry is going to be really important for how that appears. I'm going to click Templates. We can see we've got 4 templates in here. So the 3 default ones, and then I have a Hollow Road template in here. So these templates are built up with a series of components. In our roadway component here, we've got our road width set, we've got our berm height, we've got a probe parameters. So this is when do we have a berm appear. So let's just see how that behaves. As I move over here, if I don't have a drop off on the side of my road, we don't need a berm. So we're going to just use this Hollow Road template. If you open up the software and it doesn't have what you'd like for components, you can come into our eLibrary, grab all these components, and you should be able to make something behave the way you want to use it in the existing components. So I haven't changed anything here. We'll just leave it as is and hit cancel. We will assign that Hollow Road template by hitting assign by range and assigning it to the length of a road. So if we wanted to use different templates along the length of a road, we could assign it by station, but we're reusing it along the entire length. We'll just do ... so full extents. All right, now for the alignment, I'm going to right click in my plan view, add edit IP tool, and I'm going to move our starting alignment over to where I want to start the design for our new road. So we've got an existing road here, we'll tie into that, and we could click in progressively, working our way over here. I know I want to end here. I'm just going to drop our endpoint there. We can see the profiles updated now. So since it's not a single point, we can see a draped line showing what's where. And I'm going to start by making this actually resemble something. So we could click through doing both views at once. I'm just going to click in something that I think is close to reasonable for a start alignment in my horizontal, and then we'll refine it. So we've got a few horizontal IPs. We can add curves to those IPs. So just add a 100-meter radius curve, hit apply. If we weren't happy with that, we could come in here, change it to whatever radius we want. We can also do spiral curves and super elevation and whatnot, but this is assumed to be a fairly low design speed road, so we won't worry about that stuff. We'll apply our default curves to all these IPs rather than clicking through and doing it for everyone. And there's that. So we've got a preliminary horizontal alignment clicked in. Let's add some realism to our profile. So right now, as we click along there, the road is assumed to be set right on the ground at center line. So not actually what's going to happen. So behaves much the same way as our plan view. Add edit IP tool, and we'll click in a quick alignment. So there, we've got something. Now, as we said earlier, all these views are updating in real time. So if I come over here and add in an IP and lift my roadway up, my cross-section changes. We can zoom in here and see that my slope stakes also change. So the extents of my earthworks. And our mass haul's changing as well. So I'm keeping track of material deficits and surpluses. Let's drop that down. We've got a pretty big deficit right now. And that deficit is created in this vicinity. So let's use 10% for our max grade. And tweak that. So we're under our max grade there. And let's drop this one down. Oh, we're getting close to balancing. For vertical curves, we've got a vertical curve panel. We can come through and add our K values, parabolic curves as we'd like. So we'll use sags of 12 and crests of 11. There. So we're starting to get reasonably close with our alignment. Now, of course, we'll need culverts. We've got a culvert editor here. We can add in a pipe at our location. We can adjust this if we'd like. We can move it up chain. Let's go up chain to 255. Shifts it over a little bit. We can also look at our 3D view. Now it's not being displayed here. 3D options. Let's see where that pipe is. So, works for me. And we can play with our skew as well. And we can turn off auto length, change our attachment point. Let's go with 50. So we could do this all along the road if we'd like. I'm just going to add in one because it's pretty repetitive after that. For as far as reporting goes, so we've got our mass haul that's showing us material deficits and surpluses along the length of our road. We can also populate tables. So volumes are an obvious one. If we want to look at volumes in 100-meter intervals, we'll add that in there. Columns, we can choose what we want to look at. So let's do volumes. We'll look at our cut volume, fill volume, and surfacing volume. We can look at design totals. And there we are. We can see how much earth we're moving around. You can copy that to your clipboard, paste it into Excel if you want to use it outside of the software. Culverts, we can do largely the same thing with culverts. So nice to get a quick bill of materials. Point type, culvert insertion points. So that's going to control the rows and columns. We'll just look at culvert diameter and length. We'll remove these others. So there, we've only got one culvert in our design so far, so that makes sense. For output sheets, we can come into our multi-plot and we can quickly create a formatted drawing. So just going to open up an existing workbook. So this existing workbook is kind of like a template. Of course, you can customize them, make them do whatever you want, but usually you don't have to do that every time you design. It's a matter of getting things set up the way you want the first time, and then you can customize after that. Change the scale though to something a bit more reasonable. And so we've got one chapter showing us our plan and profile. We can move things around as we'd like. We've got another chapter showing our cross sections, and we can zoom out to an appropriate scale here as well. And we can set the intervals to be whatever we'd like for reporting, and so on and so forth. So that's a quick example of a design. Do we want to pause here before we go on to are there any questions, I guess, before we go on to the optimizer?
Oh, we've got lots of questions coming in, Matt.
Oh,
I might recommend getting your optimizer going because sometimes it can take a minute or two, and then maybe we can tackle a few of these questions as you've got it running.
Okay, so I'll do the normal preamble for the optimizer side of things. So our optimizer is going to minimize your earthworks costs. So for that, we need a relationship to define how much things cost. So in here, in the example I've used so far, I've just used a single material type. The default is overburden, and that's our materials are defined in our ground types tables here. So I used overburden. It's got a cut value of 1/4 to 1, fill value of 1 to 1. We've got a bunch of different geotechnical parameters here. We can also track expansion compaction factors, and we can assign these ground types along the length of our road, have different horizons, etc. So we've got the geotechnical side of volumes nailed down. We also have a cost parameter side of things here. So if we've assigned a bunch of different material types, we can account for that. So for example, easy to excavate gravel, excavation costs should be fairly low. So we assume $12 a cubic meter for defaults, place $4 a cubic meter. So placing it back to $4 a cubic meter. Something like solid rock though, where you're drilling and blasting, it's going to cost more. So we can separate the cost by material type, which makes sense. And then so that's dealing with the cut, the fill. The movement is accounted for in our movement costs. So here we've got our haul cost edit. We've got different categories assigned. So we've got free haul, overhaul, end haul, and those break down to how far the material is being moved along your road. So we can play with these values, and it's going to solve for where you should break how you handle your volume. So this is set up for probably a dozer, a scraper, and anything beyond that is going into a truck. If we change our overhaul loading cost to 80 cents, we update, it's going to change the cutoff value for how far you push with your dozer before switching to your scraper. And if you want to just define that by distance, you can go into free haul control and define it there. So that's generating the cost for our earthworks. Now, let's optimize it. First, I guess, let's see how much it's going to cost to build this using that relationship. So I'm going to go recost, or recalculate range, recost. And we've got a total cost of $10 million. All right, so let's see if we can do better. So I'm going to take this, I'm going to create a new vertical alignment. I'll just do a vertical optimization for now. And so we've added that into the list. Oops. And set it as current. So since I've added it, it's just a duplication of the previous. Now, let's set up how we optimize it. So this is going to adjust the vertical profile to minimize our construction costs based on those parameters that we have in our ground types for material handling and movement. This first page is going to just control how we're optimizing. So the optimizer is going to work by sampling along the length of our road. So let's tell it we want it to sample in 20-meter intervals. And let's tell it we can optimize 10 meters either side of our vertical band center. So to do this, you don't need to click through a vertical alignment to start. We could reference the ground. I'm going to just keep it as this vertical alignment 1 for the center. Then in the standards tab, we can control some of how this looks. So we've got our curves. So curves fast. That's going to allow us to butt our vertical curves right up against each other, so no tangents between them. We can assign our maximum and minimum grade constraints here. So let's go with 10%. And we can assign our minimum K values for sags and crests. So that's as we designed it, so it should be a pretty decent comparison. Control points. So most common control points will be at the start of the road. You don't want to start your road in a big fill. You want an intersection with something. And then we'll do the end of the alignment as well. Other common control points would be at a bridge abutment if you want to hit a bridge abutment at a certain point. We can add in pits. We won't do this for now. I think this will probably be pretty close to balancing internally, but we can account for if we need to open up a pit along the road for a material deficit or open up a waste site along the road for a material surplus. Costs we've already talked about, and constraints. We can add some more realism to the design by controlling the direction that materials moved in the optimization. Also in the output, we can control whether we'll allow side cast along certain sections of road, so linear spoil along the length of your road. If we have areas where we want a minimum fill height, we can account for that here. If we have sections we want a full bench, we can account for that here as well. Yeah, we'll leave that stuff as is, keep it pretty simple for now. And the optimization side of things, I don't see any real reason to dig into this. You can just set stopping conditions if you'd like. Display, not really related to optimization, just controls when you can see the selected alignment if you have multiple alignments. And log's going to tell us if there's any issues. So we've got the optimization set up. We'll hit vertical optimization. We'll hit process. And it's going to take a few minutes to do that sampling. It should solve solve for a minimum cost fairly quickly, but the samplings will take a couple minutes. So probably a good time for questions now.
Perfect. Okay, I'm going to go over to our list here and see if we can pick a couple of them off. So I actually handled one of these, I think, already, which was how do I get a list of all my culverts, lengths, etc. as an export, which we checked off, which is awesome. Sorry, this part's got a bit of verbiage at the front. Can RoadEng be used to create road access in the pit as related to its bench, crest and toe design?
Yep, so I don't have that prepared for now. I might be able to touch on a little bit of it now, but the premise behind that would be I would use a bit of an iterative design approach. So in our train file, we can take this pit design, we can merge that with our topo surface, and then instead of having the original ground topo surface, we can have a merged surface, including something that's designed. So we can rough in our pit and terrain, and then we can design the access road coming down into that if you'd like in location. You could also do it exclusively in terrain, but it wouldn't be as easy as using terrain and location.
Excellent. I think this is a very similar question. If we want to design other structures that intersects the pit and the existing ground, is it possible to paste these two surfaces?
Yes. So that comes into that composite surface thing that we just touched on. If you don't want to include that in your, if you don't want to merge the surfaces, if you just want to see where something is for reference, you can add that into your separate views as well. So we added the pits in this for the plan view. We can also show where that pit surface intersects with our profile here and our cross section as well. But yeah, a couple different ways you can do that. Once this is done calculating, I'll add a reference surface in for our profile.
Excellent. I mean, we've got time for just one more. I don't know our exact costs, but does that make the optimizer not usable for us?
That's a good question. No, it's still very applicable. So with the earthwork optimization, the driver is going to be to minimize material, or minimize your cut, minimize your fill, and minimize movement. So that relationship stands for any kind of earthworks construction. So we've assigned the constraints for your alignment, and it's whatever you use for values, it's going to want to minimize those. The default values, they may be high for what you use. If you're not sure, I would probably stick with the default values because it is a pretty reasonable relationship there. Or you could derive your own values going into cycle times and machine rental rates. It's a bunch of different ways you can tackle that one. All right, and we've got our optimizations done here. So our original, didn't have to hit that. Original costs about 10 million. Our optimized, we're down around So pretty significant savings. Yeah, that was just a couple minutes. I mentioned, or to touch on the other intersecting features and see where things are at. We can add in a reference surface. We can define a reference terrain. So that was in this folder. So there's those pits and piles. So we're going to reference the surface created there. And we want them displayed. And I'm just going to change the color to match the color we're using in the plan. And there we can see where we come into the pit. So for this example, it's probably going to make sense to push our access road out a little further. And then we can see whether we can adhere to the, stay in the southern portion of our pit after the fact. So we're at 14%. And we could play with the alignment to make sure we can hit something that's reasonable and maintain our minimum grade. So yeah, and then you could make it more complicated and merge those surfaces if you'd like. And you can toggle back and forth between your target surface too, so you don't have to have one design for pre-pit, one design for post-pit. You can just jump back and forth for what surface you're referring to here. All right, are there any other questions?
We do. We've got a couple more, and then we probably will wrap it up. So maybe no more questions to everyone watching. The question is, does this software have assembly tools to make benches instead of doing it manually? So I think we're looking back at the terrain model here.
Yeah, so we do in location. In terrain module, there isn't going to be as much functionality for that. We can go into the, I need to select something. Grading, there's an option to use a template, but there's, in comparison to location, there's not as much functionality in the template here. So, kinda would be the answer.
Excellent, and we're happy to follow up with some of these more complicated questions after the fact. I'm going to do sort of maybe one more here, Matt, for you. Would it be possible to prepare a tutorial showing how to build a quarry wall with catch benches and an 8% ramp going up or down? Sounds like another follow-up after the fact as well.
There's, I believe we have something similar to that on YouTube already from a previous webinar, but we can put it in the list for future webinars as well.
Excellent. Well, I think we're going to leave it there. Thank you to everyone for coming today, joining us for this webinar. We tackled a pit, stockpile, an access road, optimization, and a whole bunch of complicated questions, which is awesome. Thanks for coming, and yeah, hopefully you'll join us for another webinar in the future.
Thanks for watching another SoftTree webinar. Please be sure to subscribe to our channel below or tell us that you liked the video. Thanks for watching.